All right, so logarithm and exponential functions are inverses. So what does that mean? If y is equal to b to the x and y is equal to log base b of x, like for example, the example we did earlier page, it was y is equal to 3 to the x versus y is equal to log base 3 of x. Do you guys remember doing that over here? The very first example I showed to you? Yeah. If they are inverse, then when you compose the functions together, you better get x. This is very important property we learned 2 lessons ago. Yeah. Okay, recall 2 important properties of the inverse functions. When you graph them, each one of them are reflection across the line y is equal to x. Remember that? So you like fold it in y is equal to x, they meet one another. And if you have x comma y on the graph of the regular function, then you better have the y comma x on the inverse function. Duh. You switch x and y, that's what I mean. All right, so we have y is equal to 3 to the x power, y is equal to log base 3 of x. Show that they're inverse by composing them together. Got it. First, f of g of x. That means you take the g of x, plug it into function f. You take this log base 3 of x, plug it into x over here. Let's go. 3 to the log base 3 of x. So this whole thing goes as an exponent. Now you might be thinking, that's all we can do. Correct, that's all we can do. Somehow this note assumes that you've learned something else you have not learned. That is, we're going to learn in next lesson actually. When base and the base of the logs are the same of the exponent, you can cancel it out and you just get x. Just go with that, okay? This makes so much more sense next lesson. So when you compose f and g together, I got x. Yay, they are inverse. All right, by other, take f, plug into function g. Take this 3 to the x power, plug it into argument over here. I got log base 3 of 3 to the x power. Once again, you don't know how to do that. You don't, but you will soon. At least, do you know what log base 3 of 3 is? Yeah, 3 to the what power is 3? 3 to the first power is 3. So that's just 1. It's just going to be 1 times x is x. I know, makes no sense, but it will. Just go with that. So they are inverse. Yay. Next. Portion of that is shown 2 to the x power is graphed below. Sketch a picture of the inverse log base 2 of x on the same coordinate grid. There is easy way of doing it. There's a harder way of doing it. I'm going to do the easy way. Why not? Okay, so what I did over here is I made a table of y is equal to 2 to the x power. So those are the x value I chose, and I plug it into x. So for example, 2 to the negative first power is half. You got it? All right. What do you know about the inverse function? What happens to the inverse function, folks? Your x and y switch, right? So negative 1 comma half becomes half comma negative 1. 0 comma 1, 1 comma 0. You see? And I'm just going to plot those points. Okay, so half comma negative 1 is here. 1 comma 0. 2 comma 1. 4 comma 2. No, that's not 2. Is that 2? I can't see. I think that's 3. 2 is over here. Not this. 8 comma 3 somewhere here. Okay, so let's connect them together. Like that. Okay, what do you notice? If I were to fold this black graph in half along this y is equal to x line, do you see that it becomes a red line? So how like that graph and this graph are mirror image of one another. So it makes sense. Easy peasy. Next. Exponential function y is equal to a to the x power. We don't know what a is. Contains 2 comma 3 and 6 comma 27. Find the average rate of change of y is equal to log base a of x. All right. We don't know what a is, but what relationship do you know about y is equal to a to the x power and y is equal to log base a of x power? Miss Major, I don't know. Well, let me give you a hint. Look at the top problem. 2 to the x, log base 2 to the x. What were those two? I don't know, Miss Major. Well, 3 to the x power, log base 3 of x. What were these two? Do you know how to read? Yes. What does it say? Inverse. What does it say? Inverse. So, they are inverse of one another. Yay. So, if the original passed 2, 3 and 6, 27, can I say that this inverse logarithm function is going to pass 3, 2 and 27, 6, right? Your x and y switch. Are you good so far? Yeah? All right, and it says find the average rate of change over interval 3, 27 over 3 to the 27. So, in other words, you're going to find the slope, average rate of change between these 2 points. That's all there is. So let's go. How to find the average rate of change? Change of x goes in the bottom. So what is the change of x? x2 minus x1. If that's how you want to memorize it, that's fine. Over, that goes in the denominator. Numerator is going to be y2 minus y1. 1/6 is going to be the average rate of change. So this one's kind of sneaky. Like, it didn't really say explicitly, but you were supposed to understand how, okay, they were inverse of one another, so that means it's going to pass the inverse, like you switch x and y, and then use those 2 points to find the average rate of change. Okay? All right. That is really today's lesson. Obviously, I skipped a few things here and there, but I cover all the main idea of it. Please go ahead and do your 2.10 IP. Good job. Thanks.